All right, cool. So I'm just going to get started now, actually. So like I said, my name is Dustin Schau, and today I'm going to be talking to you, teaching you about CSS and JS. And so first, though, I just wanted to say how well organized and well-run this conference has been. The organizers deserve a huge round of applause, but let's save it until the end of this talk, so it seems like I have just a massive amount of applause for this talk. Also, I've noticed that a lot of these code snippets in each of these talks can be a little bit hard to read, so my slides are hosted at that URL, so you can check that out and then pull them up so you can see them a little bit more clearly. And so the kind of high-level agenda today of what we're going to talk about is we'll start with some drawbacks of CSS that led to the creation of some of these libraries we're going to be talking about. We'll then discuss advantages of CSS and JS over CSS, and then shift to some common patterns, utilities, and libraries to instrument CSS and JS. And then we'll finally end up with an illustration of the drawbacks of CSS and JS. And so the kind of main goal of this talk is that I want each of you to leave here feeling empowered, whether you like these techniques or whether you don't like these techniques. But I want you to have actual valid reasons for that belief, and I hope this talk gives you that. So who's this guy, and does his opinion matter? Does he know what he's talking about? Well, I think so. I'd like to hope so. So I'm a front-end developer specializing in all things JavaScript. So throughout my career, I've done a fair bit of everything. That's Angular, React, jQuery, web components, you name it. Of course, this is a talk about CSS in JavaScript. I've also done a fair bit of everything in CSS land. So whether that's vanilla CSS, whether that's using preprocessors like less and Sass, using CSS modules, and then, of course, the kind of gamut of a lot of these CSS and JS solutions. I'm from little old Omaha, Nebraska, which I think a lot of people think looks like this slide background. Cornfields and a vast void of nothingness. And so I'm happy to report that's not quite what Omaha is. Omaha is actually a pretty cool city. This is the downtown. This is actually, I live just off screen, a little bit to the left. But Omaha's been a great city for me to live for about 8 or 9 years, and I'd highly recommend anyone go check it out. There's some really cool things going on as far as it's a good city to live in, as well as some really good like technology things. We have a lot of local meetups, just like we do here in Oklahoma City as well. And so in Omaha, I work for a great company called Object Partners. So we specialize in JVM and front-end development of all sorts. And so between Omaha, Minneapolis, and Chicago, there's about 100 or so consultants. And so if you'd like to learn more about Object Partners or what I do at Object Partners, come talk to me after, and I'd be happy to talk about it. I'll also have some T-shirts and some other swag to bribe you to talk about this stuff. So every presentation has this sponsor slide, but they truly deserve so much credit. Without their support, we wouldn't have all gotten together for this great conference, so it is sincerely appreciated. Thank you to each of these sponsors. And so I think this is what a lot of people, this is kind of their emoji representation of their inner feelings towards CSS and JS. I think most people have a pretty negative perception of this stuff, or at least not an overtly positive perception. And so this can be for a variety of reasons, but I think paramount for some is that it goes against this whole separation of concerns that has been ingrained in our minds and then regularly reinforced. It can feel weird, it can feel unclean, and it can even feel like a solution looking for a problem. And so my goal today is to take you from that initial possibly negative stance to what I call cautious skepticism, so this phase. And so I hope you leave here with an understanding of why CSS and JS exists and how it can solve some very real developmental problems. Perhaps it might not be the perfect fit for your application at this point, but you can understand why someone else would adopt some of these technologies. And so I'm an optimist, and so I have a stretch goal, and my stretch goal is that many of you will leave here fully convinced that CSS and JS is the solution to some of your CSS problems, and you'll adopt these techniques for your next application. So like I said, let's start with a brief discussion of some of the problems of CSS. And so an important caveat here, I kind of quantify these problems as what I call real-world problems, or problems that everyday developers like myself have run into, or have run into without quite realizing it, and then resorting to hacky workarounds. And so this is not to say that problems at scale are not important, but if we can narrow the scope to problems that everyday developers have, we can more clearly define the problems in more approachable terms and concepts. And so in illustrating these real-world problems, the foundational basis for the creation of these CSS and JS techniques will be made evident. So let's start with a brief series of examples. Hopefully that code is mostly readable. So for these first examples, let's say that we're a team of front-end developers working on a component library to be used throughout a company's internal application suite. We get business requirements from users, and they're filtered through our UX department, who weeds these out and gives us the truly important requirements. And so our first task from the UX team is to design a button component that has a hover state and raises slightly on hover. We designed this using what we know best, so vanilla CSS and HTML. And so this button looks great. It meets every current need we have, and the code is quite succinct to boot. This is a pretty great component. And so a week down the road, our UX team makes another request. So we now need a secondary style, and this secondary style needs to be inverted and needs to look slightly different. And so we add this secondary class, we complete this objective, and we're still feeling pretty good about our component. Another week down the road, we get another request from our UX department, and they say that this button's far too large for this one or two particular teams. And so we need to reduce the font size, shrink the padding, and then so that they can put just a bunch of these buttons on the screen. So we add this tiny class, we complete the business requirements, this is fine. We get a final request that the button needs to have a hover state for accessibility and more intuitive feedback on desktop screens. So we add this secondary hover class, and our button is completed for now. This is not fine. And why is that? So our clean CSS, what started off so great and so simple, is no longer so clean. We have the secondary class, we have this tiny class, and then we have the secondary hover class. What we've effectively done is that we've introduced globals. And so each of these simple requests from that UX team has stacked, and it's increased the complexity of the component. In effect, we've introduced a number of globals. And so as anyone is aware, globals are a common enemy of any code base. And the introduction of globals will make this CSS harder to maintain, harder to use, and then harder to develop against. And so it's especially evident if you're working on something like a component library, where hundreds of other developers in our company will use this button, extend upon it, and introduce their own globals into this big mess of global ecosystem. And so it's incredibly easy, I think, to imagine a scenario where collision occurs, and I think this practice makes this approach untenable. So as an example, let's consider the usage of this button component by a developer who comes on the project a couple months down the road, far after the team that designed the component has left for greener pastures. This developer is relatively inexperienced and just needs to get something done. And so he or she has a requirement that they need to add a link to their application that looks kind of like a button. And so they use these classes, this button and the secondary, and they're kind of confused because they're like, well, I didn't add any of these colors. Where is this coming from? And so just to get it working, they hack around this. Where is my mouse? And so they add these important hacks, and then they get it working. Let's say a week down the road, they have another request, and they add the secondary class, they modify the color, the background color, and again, they get it working, but they're resorting to this hacky use of important. But I think some of you might be jumping ahead, but wait, we've invented techniques to solve these problems. Things like BEM. So BEM is a naming methodology that is block element modifier. So in this example, the block is on the left side, the form, the element is submit, and then disabled is the modifier. And then on the right, you consume these classes. And so this actually does solve, for the most part, this global problem. It's pretty unlikely that someone is unknowingly going to apply a class like that in their HTML in a separate place, so that those collisions and this global problem are mitigated to some extent with some of these naming methodologies. But when I see these, I'm very much not a fan of these methodologies. They introduce cognitive overhead and introduce naming concerns. Is this particular thing an element? Is it a modifier? Is it a block? Naming is already notoriously hard. This technique certainly does solve the class name collision problem, but I contend that it imposes extraneous concerns on behalf of the developer that can be solved in other, cleaner ways, as we'll see soon. So there's this great quote that actually just came out yesterday on Twitter, and he says, "BEM is safety through discipline. CSS and JS is safety through API design. The former works, but can be easily broken. The latter will always work. That being said," and this is really true, keep using a tool that works. No reason you can't love both. And again, Kent C. Dodds says, "I don't use CSS and JS to be cool or hip. I use it because my brain is limited, and CSS and JS automates stuff for my brain." And so this really gets to the crux of the issue, I think. Why would we not use tooling to automate trivial naming concerns? Development is oftentimes all about automating hard problems. And is naming not one of the most unnecessarily difficult ones that we face? And so again, I think some of you might be jumping ahead of me here a little bit. There are things like CSS modules and concepts like Shadow DOM that again kind of alleviate this global problem. And so I'll just first say that CSS modules, if anyone's a fan of these and if anyone has used them, that is CSS in JS. You typically instrument it with some type of build process. You use CSS as authored, and then it creates a unique hash. So if you leave here with nothing else, definitely consider CSS modules as a solution to this global problem. And then, so similarly, Shadow DOM is another technique that will allow you to kind of mitigate this global problem. And so I'm actually a really big fan of Shadow DOM with one big caveat. So Shadow DOM doesn't have like perfect browser support. So if you want to use this technique, you certainly can. It does some great things, but you'll probably have to ship a polyfill to some certain subset of users. And so I think Shadow DOM and then web components as a whole are certainly something that I think is going to be a real growth market. Like, definitely keep your eye on these things. But that said, I wouldn't necessarily consider this the end-all, be-all solution for my application today. So let's talk some more about some problems. So CSS does not scale. And so this previous button example, I think, kind of showed this issue. So the bigger your application gets, the more CSS you write, the more globals you will create, which is quite simply making your application harder to maintain and harder to use. And so in order to work around some of these inherent issues, we've used naming strategies, like I said, like BEM, or oftentimes tooling, like Sass and Less, to kind of mitigate this problem. But I think CSS and JS solves this problem cleanly, clearly, and simply. And so I do want to make a note here that pretty much whenever I hear the term does not scale, I think that's kind of an indication the person just doesn't like this technology. And that's really not the case here. I think the people who are most active in this CSS and JS community are arguably the ones who are using CSS the most, and you're still using CSS when you're using CSS and JS. And so I think the people who are using these technologies are also some of the biggest users of CSS. We love CSS, we love writing CSS, and I think you'll see that when these two are kind of married together, you can do some really cool things. So let's talk about dead code elimination. So when you're writing in the traditional non-CSS and JS model with separate CSS files, separate HTML files, your class names and styles, so the CSS files, are separately located to what is being styled. So typically JSX with the class name or separate HTML files. And then as previously mentioned, CSS is global by default. So your styles could be styling unrelated functionality in your application. So you could have some innocuous class that you think isn't being used, but some other component or some other developer in an application could be using this class and you'd have no idea to know that. And so jointly, these two concerns make it incredibly difficult to refactor unused CSS. And so down the road, if we want to get rid of a component and we want to get rid of its associated styling, that's actually a pretty hard task. And so it can be a pretty spooky endeavor. So many regression tests, a good QA department, or manual testing is often required to validate with certainty that only certain functionality was impacted. And so each of those, each of these techniques requires some level of manual intervention, and is not something that every developer even has available to them. And so CSS and JS gives you confidence that by removing this particular component, you're only removing style code applicable to that component only. So sharing constants. So theming, other stylistic concerns like padding and line height, and other possibly shared constants are a natural and intuitive fit to be co-located within your JavaScript. Want to reuse that branding color for a button? Sure makes sense to share that with your CSS and JavaScript. Media query breakpoints, another intuitive and obvious fit. So we have here how I've actually done this before, or how I've seen a lot of people do this. We have our CSS on the left, and then on the right we have our JavaScript. And so we have this background color for this button, and I don't know if you can read the comments, but someone commented, keep in sync with button.js, and then on the right, keep in sync with button.css. And so this is just a very brittle process, and it will inevitably fall out of sync or require tweaks at some later point. And so I asked the question, why not use one source of truth for all application constants? And why not make that source of truth a JavaScript file with CSS and JS? That sure makes a lot of sense to me. And so I just wanted to give credit where credit is due. You probably definitely can't read that, but it's from a talk given by a developer at Facebook, Christopher Shadow, and it was actually way back in 2014, and he kind of identified 7 major issues that Facebook was running into. He called it at scale, and then he proposed this CSS and JavaScript technique called inline styles that a lot of you may have heard of. And so I just wanted to mention that this was a formative moment for a lot of this community, and so I linked to this at the end, but definitely take a look at these slides or watch the video for this talk. It's a very interesting and informative talk. So at this point, I think a lot of you are thinking, all right, this guy's pretty negative on CSS, and so I have an anecdote. So early on in my career, I was in a meeting where I criticized a proposed solution that I thought to be poor, and then I kind of just left it at that. And so there was another person in the meeting that said, if you can't bring anything to the table, then don't say anything at all. And so while the character of the message was delivered imperfectly, the content of the message still resonates with me. It's easy to criticize something. It's far, far harder to criticize something and propose something better or that could be better. So at this point, the discussion will shift into what CSS and JavaScript is and how it can fix some of these aforementioned problems. In other words, let's bring something to the table. So first, a just really big disclaimer. CSS is not broken. It's not CSS in JS or CSS. It's CSS in JS with CSS. So the CSS that you've formerly written can continue to be written with this paradigm shift. The best parts of CSS are maintained, and for the most part, the ills of CSS are remedied with these new approaches. And really the kind of rallying call of this whole idea is, maybe we can actually make CSS better. Maybe by recontextualizing the problem and bringing the power of JavaScript to CSS, we can solve some actual problems with CSS. Maybe there's actually some validity to this practice. Maybe it can really improve the quality and maintainability of our applications. Maybe we'll see. So first, let's take a step back. There's this quote from Ben Lesh, and he says, I'm moving from storing my CSS, JavaScript, and HTML in different files to physically putting them on separate drives. Got to keep those concerns separate. And so he's really, ironically, or he's sarcastically pointing out, this really goes against everything we've been taught about separation of concerns. HTML in my JavaScript was already enough of a shift, but this, is just too much. It goes against the hypermodularization we've seen in the JavaScript ecosystem. It just feels wrong. So I would counter here. It's separation of concerns. It's not separation of technologies. It is incredibly likely that the rendering of a component will require intermingling between HTML, CSS, and JavaScript. And if we can make this intermingling as clean as possible, that's a win for code clarity and maintainability, not a loss. So there's this slide that's kind of been making the rounds in a lot of these talks. And on the left, I think, is what people think of when they think of a component. It's these 3 separate blends of technologies blended entirely separately. And then I think that on the model on the right is actually what a component is. It's a seamless mix and blend between each of these 3 technologies. And you see this blurred gradient. A component isn't disparate JS, CSS, and HTML. It's incredibly likely that it's going to be a seamless blend of each of them. So let's start with a definition by contradiction. So in other words, what CSS and JS is not. So it's not, or at least not exclusively, inline styles. And so while inline styles are certainly an example of what it can look like, I don't think they're necessarily the best implementation for a variety of reasons. So first and foremost, only a subset of CSS is actually supported. So things like pseudo-styles, hover, and focus, and before and after, media queries, and a number of other useful and required CSS functionality is not supported with this model. Additionally, inline styles can be difficult to override, which makes components that use them historically harder to extend. And so when I say inline styles, this is what I mean. This is JSX. It's a style that's authored inline, and then, like I said, the drawbacks that apply here are you can't use anything like hovers, you can't use media queries. So while it is CSS and JavaScript, as we'll learn soon, I don't think this is the best example or the best implementation model for what we can actually do with some of these technologies. So, I think on slide 35, it's about time to talk about what it actually is. And so we'll go over some high-level goals of CSS and JavaScript, as well as some common patterns and coding techniques for what it can do for a modern application. Additionally, detail will be provided for how it actually solves the aforementioned problems of CSS. So at its base, it is abstractions upon CSS. And so CSS, actual vanilla CSS abstracts style to the document level. So when you think of what the web originally was, it still is, it's a document. So, it's paragraph tags and first level headers and second level headers and lists. And so CSS was intended to be a global style for these documents. And so CSS and JS abstract style to the component level. So in a similar way that React and Vue and Angular, etc., are abstractions upon JavaScript, CSS and JS abstracts upon the base model of CSS, and I think fixes some of the inherent issues. One of the ways it does this is with true encapsulation. And so like I said, with naming methodologies like BEM, we can get kind of pseudo-encapsulation that's a manual process. With Shadow DOM, we can get true encapsulation at the component level, but it requires a polyfill and several browsers, and isn't quite at a point where I think it's a perfect solution for any application. So with CSS and JS, we can get true encapsulation at the component level today. How it actually works technically, under the hood, a unique hash will be generated for the class name, and a real style sheet will actually be created with the class. So this allows us to target a unique element, a component, today without polyfills and in an automated way, so we never again need to waste cognitive cycles constructing meaningful isolated class names. It's also a more powerful CSS, so leveraging the full power of JavaScript lets us extend CSS in new, interesting ways. We can create a mix-in, just like we can in Sass and Less. We can use helpers to lighten the color, darken the color, share style code. We can, of course, easily share constants and modify them as needed. And we can do all of this in a language each of us are familiar with, JavaScript, and without learning or remembering the syntax for doing so in Sass, Less, etc. So it's also real style sheet. It's real style sheets. So a real style sheet gives you the best parts of CSS, media queries, pseudo styles, flexbox, all of the properties and rules that you know and love in CSS. It lessens the bad parts of CSS, namely globals, by scoping to a class name and doing that true encapsulation. And so if you already know CSS, that's great. CSS and JS presumes that you do. The properties and rules, etc. of CSS that you already know continue to function just as they do in vanilla CSS. So let's take a look at our first example of what I'm calling kind of the way I would like to consider CSS and JS at its best. And so this is using a library called style components that many of you may have heard of. You just npm install this, and it's available to be used in your React applications. And so the code actually, it exports this function, and this function has a number of properties. And so you can see here, you see style.button. And so you can put any HTML tag in place of button. You can put a div, you can put a span, you can put an h1, and it'll construct an actual HTML element with that element type. And then you pass styles as a template string. So it looks exactly like CSS because it is CSS. And then so under the hood, style components will then construct this style tag. It'll inject it into your head tags, and then it'll construct that unique class name. And so you can see there that unique class name will actually be automatically added to your button. So there's no manual adding or anything like that. It's using automated tooling to solve this true encapsulation and also to solve this global problem. So it's also a component styling solution. So CSS and JS bring CSS into the component era. We've removed globals from our JavaScript. Why should we not do the same with CSS? We've established a component model for our JavaScript. Why not bring CSS into the fold and enhance upon this model? It's also a JavaScript styling solution. So using JavaScript to write styles feels incredibly natural and intuitive, especially when considering the previous arguments we've made concerning sharing of constants, using JavaScript functions as mix-ins, etc. And so there's another big benefit here. We are creating distributable single import components that are entirely encapsulated. No configuring of Webpack loaders, no loading of additional style sheets into your HTML tags. One import, highly shareable, highly consumable, and highly simple. So it's also semantic elements. CSS and JS gives us truly unlimited semantic elements. So HTML5 gave us header and footer and section and aside, among others. And CSS and JS gives us truly unlimited semantic elements that are semantically clear at a glance. So things like logo and branding and toolbar and copyright. The possibilities are really endless. Oops. So you can't really see this slide. But on the left is the HTML5 equivalent. It's an attempt to be as semantic as possible using those HTML primitives that we have available to us. And On the right, we have the equivalent in CSS and JS. So we have here, a styled header. We have a brand. We have a logo. You take one look at each of those tag names, and it's very clear what the intended purpose and what the intended meaning is of those components. So again, you can compare. Like when I look at this, I see class name header dash dash brand. I can kind of intuitively figure out, after some thinking, like, oh, okay, that's a brand. Same down here, header dash dash user. Oh, okay, that's a user header. Contrast with user container, username, etc. So on the left, we have here the mental model that you have to keep in your mind when you're writing vanilla CSS, vanilla HTML, or JSX. And then on the right, there's the mental model for when you're writing CSS and JS. So in the model on the left, you must be aware that a class we apply in HTML is styled with the class name. We must be aware that these class names can cascade and stack, sometimes interfering in unforeseen ways. These cascading rules then become style sheets in our DOM that can themselves conflict. And so the model on the right is write HTML or JSX that is encapsulated with component scope styles. There's no stacking. Never worry again about CSS rule specificity, and most importantly, no important hacks, and truly think in components. So at this point, I think and hope that the case for CSS and JS has been made apparent. These techniques solve real problems of CSS, but how do they solve them? What libraries exist to implement these CSS and JS techniques, and what does writing code in each of them look like? So first, a caveat. Most of these libraries are tied to React. However, not all of them are tied to React, and I'll specifically point out libraries that do not require React. So in general, libraries that simply export a function that creates a class name are typically framework agnostic or library agnostic. And then some of the most interesting libraries expose several libraries. So the most basic can be used in a framework agnostic way, and then they have extensions that let you, for instance, write using this library in React and using some helpers. So first, let's talk about style components. So style components is what I would call the gateway drug to CSS and JavaScript libraries. You author using template strings, so you can write CSS not as an object, not as an inline style, but as a string, and dasherized just like it's authored in CSS. And so this means that style components is probably the easiest to get up and running with, and I would recommend it to get your feet wet with CSS and JS techniques. In addition, it's a great choice for beginning to move off of a formerly vanilla CSS codebase because you can generally reuse most of your existing CSS with some small modifications here and there. And so what the code actually looks like is here. So we have this button, and like I said, this can be any HTML element. And then we have, an actual CSS rule, background color, border. And then here's something kind of interesting. So this is props injection, and most of these libraries support props injection. So this is a regular React component. So when primary is true, it'll then apply this primary style. So when I've added this primary prop to this button, then I'll load this primary style. So it's a really clean way to kind of implement what we showed earlier with that button component. And so let's talk about Glamorous. So Glamorous built on some of the ideas of not only style components, but also Glamour, the library that powers much of Glamorous's underlying functionality. And so, like I said, I would make a note here. Glamour, the underlying library, is framework agnostic. And so the real central difference with Glamorous is that it expects objects, similar to the kind passed to inline styles, but that can also be merged with subsequent objects, and that can also accept things like media queries and pseudo-styles. And so it might seem more natural to begin using style components, but as of late, I found myself increasingly drawn towards and really liking the functionality available in Glamorous, particularly with the style objects. So things like merging and conditional applying of rules, etc., feel very natural with Glamorous. So let's take a look at the code. So the code looks pretty similar to style components. You use this HTML element, but rather than using a template string, we're actually here using an object, which needs to be camel cased, but just like an inline style. And then here, so the actual Glamorous function can take 0 to n arguments. And if one of the arguments is a function, it'll inject it with the current props at that moment, and it'll change when props change. And so this is an implementation of the exact same component and style components, but using Glamorous. And so what will actually happen, it kind of works like object.assign. So it'll take this first object, and then any subsequent objects after that will be merged with this base model. And so the end result of this component is when your primary class is set on this React component, the primary prop, background color will be this, and it won't have a border. It'll be merged in order. So let's talk about Emotion. Emotion is another excellent library that feels very similar to style components because it also allows for template literals to inject styles. And so the key difference, and I think a particularly interesting idea, is that it ships with a Babel plugin, which attempts to precompile the non-dynamic styles, thereby reducing the payload of the resulting bundle. So in general, I think the ideas of minimizing or removing entirely these runtimes that are exposed is particularly interesting, and I think it'll definitely remain an area to keep an eye on as the community matures and develops further processes and tooling. So I'm not going to go over this a whole lot because it looks pretty similar to style components. The main difference is that it's not style.button, it's style with the function call, and then this string, which is the HTML element type. And so if you're looking for a similar API with some other benefits and trade-offs, definitely consider Emotion as a very solid alternative. So Polished is a framework and library agnostic collection of utility methods for CSS and JS functionality. Some have described it as the Lodash of CSS and JS, and I think that's a very fair comparison. So many helpers and mixins are provided for usage in any CSS and JavaScript library, and functionality such as lighten and darken and RGBA, so you can adjust transparency channels. Each of these are functions that can be utilized to do some really useful things in your application. So let's take a look. So Polished, just like style components and Glamorous, is just a library available in NPM. And there are a number of utility methods, kind of like mixins and Sass and Less, if anyone's used those, and that can then alter the passed-in colors. So we have this primary style. It's a light style. And then we also have this secondary style where we're using some of these methods. So you can see here the base is like a light white, and we can use this invert method to give us back a dark color. This accent is blue. We can use this complement, which will hue shift it 180 degrees, thereby creating yellow. And then finally, we have text, so we can lighten by 0.5 or 50% this base text color. So we'll take this fairly dark gray and make it into a much lighter color that'll look great on this base dark theme. And so these are the methods exposed by just the color functionality of Polish. So there's a bunch of really useful ones. I'm not going to go through each of them. But yeah, they're really, really cool. But I would like to note that Polished also has a number of other utility methods. So there's M and Rem helpers. There's radial gradient generators. There's a CSS reset, so kind of like normalize.css. And there are a bunch of shorthands for common things, such as text overflow ellipsis, font face, etc. And so if I had more time, I would love to cover every major library that can be used. Unfortunately, in the interest of time, I'm only able to cover a few. And so that said, there are seriously so many libraries, and it seems like there's one every couple of weeks, that are really worth looking into and worth investigating for your application. And so I have this slide because every one of these libraries is framework agnostic. And so they're definitely worth looking into, because if you're not a React person, each of these can be used outside of a React context, among many more that didn't make it into this slide. So even if you're not a React person, don't see this presentation and see some of these really cool libraries and think, well, I can't use these techniques in my application, because you definitely can. So let's talk about NPM downloads. In general, style components and Glamorous are kind of 1 and 2 on the popularity spectrum. And then of course, because Glamorous uses Glamour, Glamour is going to have more downloads than both of them. And so I just think it's a interesting graph to look at, because it'll give you an idea of what the relative popularity is of these libraries. But I want to make a really heavy caveat here. Don't choose your library based on download count. That's kind of following the whole hype-driven development thing and all that kind of stuff. But what it does illustrate is it illustrates the relative community and the relative kind of things you're going to see active in this community. So style components and Glamorous, like I said, tend to be pretty active. There's a lot of stuff going on in both of those libraries. Same for the other ones as well. So again, I think it's just useful to see GitHub stars. So style components is far and away the #1 most starred library. It has almost 11,000 stars. Next closest is Radium, which is one of the first CSS and JavaScript libraries, which has about 5,000. So style components is very, very starred, very, very popular. Seems to be the real big dog in this scene. So also library size. So these are the gzipped file sizes of each of these libraries. And I kind of just included this slide to illustrate that you're shipping a non-null payload to your end user. These libraries have a cost, and they're going to increase the size of your bundle by a relatively small amount, but something to consider. And so I think the functionality provided, the problems we're solving, like true encapsulation and props injection and other things, are really worth this file size. But you need to ask yourself that question on whether or not 40 kilobytes is too much, and whether or not you think the benefits are worth this 40K. Style components tends to be the largest. Glamorous is about 25K. So they're pretty small in the grand scheme of things, but definitely something to consider. And so these are actually the companies, I think this is from Style Components documentation, that are using CSS and JavaScript libraries, I believe, in production. So we'll see PayPal, we'll see Microsoft, Target, some really big companies. And so to me, seeing these companies using these techniques lends some validity to the practice, and it makes it more obvious that there's some real value being generated by the usage of these libraries. So let's talk about real-world usage. And so I think it's important to actually show some real-world usage and common patterns for writing code in each of these libraries. So common things like theming and utilizing props, inheriting and composing styles, etc. And so one note here, I'm not endorsing any particular library, so I'll jump around a bit between each of them to hopefully give you a feel of what writing code in each of these libraries feels like. So this is using props, and most of these libraries have some capability of tying into props, which is a very React-y way of altering and augmenting style. And so, for instance, we have this container, which is a main element, and then we have this padding rule. And so when this container has a padding property passed, it'll use that padding, otherwise it'll default to 0. Similarly, we have this button, and we've kind of seen this code before. When props is inverted, then we apply this style, and it'll be merged with what was previously written. So that's utilizing props, and it actually feels like a very natural React way of augmenting these components and conditionally loading and then rendering styles. So inheritance. A common question is that one of CSS's really great features is inheritance, an easy extension of base classes. And so inheritance is typically accomplished in these libraries by injecting a previously styled component and adding additional styles as needed. All previously defined styles will be merged with or possibly replaced by the new styles. So let's look at Glamorous. So Glamorous is a function call which takes an object. So we have this base level alert, and it has these three rules: background color, color, and then padding. But we also want a danger alert, and we want this to be red, and we want the color to be a darker red. And so we can inherit from the styles and alert, so it'll have all of these styles, and then we'll merge on top of these new styles. So the end result of this will be background color red, color a darker red, and then this padding that we've inherited from this base level alert. So I just really want to drive home here. You're writing real CSS, and so real CSS and then real style sheets are added to the DOM. So the value of CSS remains, but with the clear and numerous benefits that CSS and JS provides. And so you can see here, you can use a hover. You can use a media query. You can write everything you know and love in CSS using these libraries as well. But what about animation? Animations inherently require a global animation name. And so most of these libraries include some type of helper utility to return a unique identifier or a unique hash for those animations so that globals remain stripped from the code base. So this works kind of similarly to how the base level functions work. So we're using this keyframes function. Based on the content, based on the style content, it'll create a unique hash. And then this zoom in can then be used in place of an animation name. So this is how you eliminate globals from animation, just like you've eliminated it as a class name. So this is really more of a best practice than anything else, but if you're designing a component library or a component and want to make it CSS and JS friendly, consider exposing the class name prop for consumption. And so most of these libraries work by injecting a class name into the pass name component. So if you take this class name prop and then utilize it, you're effectively making your component CSS and JS friendly, which is a really nice benefit. Additionally, if they're not using CSS and JavaScript, they can still pass a class name and then customize it that way. So there's really no drawback to doing it this way. So external libraries, things like Bootstrap. So Bootstrap requires a large amount of class names. And so you can use some of these libraries to actually construct a React component that'll apply these class names based on the passed in props. So earlier I kind of lied. I said that every argument to the glamorous function requires an object. It can actually take a string, and that string is then assumed to be the class name. So what we have here is we have this div with the class name of alert, and then we have this props function. And so it'll then add props.type. So when you have this type prop, this will end up compiling down to a div with the class name of alert, and then alert-success. So this is a really cool React way of consuming this library and making this a component that you can reuse pretty effectively in your application. So some of the time, it may be necessary to inject globals, in particular when targeting HTML, body, your root element, etc. And so for these times, most libraries include a mechanism to inject a global into the DOM style tag. So style components has this method inject global, takes a template string, and it works just like a global style. It's going to construct a style tag in our head tags with these properties. Pretty simple stuff. And so nesting is supported in most of these libraries, but one caveat here, I think it can be seen as kind of an anti-pattern in certain circumstances, especially if you're targeting a child selector. So I will say that style components documentation mentions that used sparingly, it's a great way to lighten your code by reducing the need to create explicit classes for every element. So use this with caution, but it can be a decent technique to lighten some of your component styles. So you can see here how it actually works is it's creating this star selector, and then inside of there, not the first child. And so this is nested selectors, just like you're used to in CSS. So let's talk about theming. Theming is a particularly common use case that I think can be semi-difficult to architect cleanly. Most of these major libraries expose a theme provider component, which can be used to provide a theme via React context to each style component. So it is, for instance, incredibly easy in each of these libraries to make a light and a dark theme, or any number of color variants. And so let's look at theming. So we're going to use Glamorous, and like I said, each of these libraries exposes this theme provider component. This is a React component. We have a JavaScript theme, so we have a light theme, we have a dark theme, and then we have a current theme. And this current can be augmented via an option in the application, or like a light switch or a light toggle that can then swap between light and dark. We then have a container, and like I said, you can use props injection to access the current props. And by default, when you're using this theme provider, it'll inject theme into each of these props. So here, the background color will be the current theme's background. And then in our root level component, so typically app, we have this theme provider that's at the root, and then everything inside of there will have that exposed theme injected to it. So this is a really, really clean, simple way to architect theming in some of these libraries. So let's talk about drawbacks. There really aren't any silver bullets when it comes to front-end web technology. There is a library to do everything. And so while CSS and JS may seem like a great fit for most applications, there are certainly some drawbacks that are worth considering. So first and foremost, what do we do when JavaScript is disabled? And that can actually still be a concern. So according to some estimates, about 0.2% of users will still have JavaScript disabled. So in these circumstances, how do we progressively enhance, which I think is a key element of a good application. So if CSS and JavaScript is our styling and rendering solution, we're serving effectively an unstyled mess of content, which goes directly contrary to the ideas of progressive enhancement. So while 0.2% of users may not seem like much, there's one time I'll mention scale. If you're driving Facebook scale, or even a large application, if you have 1 million monthly users, that means 2,000 users a month may not be getting a usable site. So how can we fix this? And there are a number of techniques we can use. You can mitigate with server-side rendering using something like Next.js. You can also statically render to HTML with something like Gatsby. And so both of these allow you to progressively enhance to serve a usable application to your end users, and then from there, then use that client-side JavaScript to enhance that initial payload and that initial experience. So you probably definitely can't see that image, but this is Twitter Mobile's Twitter's progressive web app that they shipped a couple months ago. And it actually does use one of these CSS and JavaScript techniques or one of these libraries. And so Rich Harris says, "Rest in peace, readable class names, murdered by CSS and JavaScript. Another nail in the coffin of the scrapable, view-sourceable web." And what he's referring to here is because you're getting the benefits of that true encapsulation, it's generating that unique class name, it's also making it harder to know what things are when you're looking at the compiled source. And so, while I think it's not necessarily a huge issue, things like end-to-end tests or integration tests should not be pointed to that unique hash. And so it's certainly a best practice to either use one of the existing Babel plugins that can add a humanized class name, generally what your component is named, or just manually add the class name so that you can then use these end-to-end tests, and also if you care about the compiled output as well. So next, editor tooling. On the left is CSS and JavaScript solution. I'm using Glamorous, and I'm typing color, and you can see it's logging console.error. It's giving me that as IntelliSense. So that's not really what I want. I want color, color CSS properties. And on the right, we have a CSS file, and I'm typing color, and I'm getting all the available options for color. IntelliSense is working as I expect. And so editor tooling is really still in its infancy, but as CSS and JavaScript continues to grow in popularity, I think we'll see marked improvement on this front. And so, for example, this is an Atom plugin using Glamorous, and you're getting autocomplete. So you saw display, and it gives you all the options for display, font size, etc. It's giving you that IntelliSense that you'd see like in CSS. And so it seems like every week there are new developments to get this working as seamlessly as possible. And so I believe this to be a space that will continue to see rapid improvements. So this is a really weird one that I was not aware of. So user input must be sanitized. If you're directly taking user input, let's say a text field, and then injecting that as a prop, that actually opens yourself up to some issues. And so there's this really great article I linked to at the end in React Armory, and he showed a proof of concept where you can actually spy on a user's password using CSS and an AJAX request that you can use if you directly inject props from a user. So if you are doing that, sanitize it first, or just try to not do that if you can. So performance is kind of a wild card here. It can be a concern, but the kind of main thing I want to say here is don't prematurely optimize. The difference between each of these libraries is arguably minimal, and the actual performance difference between inline styles or CSS and some of these libraries I think is relatively minimal as well. So if you're pushing Facebook scale or after measuring your application's performance, you're running into performance issues, then at that point, then optimize. But I think the benefits these libraries provide are worth some possible perceived performance loss. So I do have some benchmarks. See style components has about so this is actually measuring render time. So style components is about 103 milliseconds. Glamorous is a little bit higher by this particular metric. Emotion is about 140, etc. Inline styles are about 30 to 40 milliseconds. But so I do want to note here that benchmarks in general should be taken with just a massive grain of salt. Most benchmarks are constructing some 10,000 row list and then rendering like paint time. And I don't think that is at all representative of what people are actually developing in a real world application. So while it might seem here that these libraries are quite slower than these other non-libraries, don't take this at face value. Use it in your application first, check it out, and then see if they're for you or not. So what should we make of all this? And I think there's some really high-level points. CSS and JS solves very real problems of CSS. It does so in a clean, component-focused, and developer-friendly way. It abstracts the CSS model to the component level rather than the document level. And it leverages the full power of JavaScript and the JavaScript ecosystem to enhance CSS. So if I were to give some advice, or a call to action, I would give this. Start with style components as a starter or a final library. Like I said, it tends to be the most approachable as it uses actual CSS syntax rather than style objects. And so if you're a fan, consider experimenting with other libraries in the ecosystem. Who knows? You may like them more than style components. And so it's seriously as easy as this. You run yarn add style components or npm install style components. You integrate it into your React component, into your React library, just as any other import. And then you can then start using these techniques. So it's very, very simple to get started. It takes literally 1 minute to get this set up. So overall, I'm very enthused with the direction that CSS and JavaScript is taking and the things it's doing for the ecosystem. I think it provides very tangible benefits to any application, particularly in the approach it takes to solve some of the problems of CSS now and today, and does so in a way that feels like a real improvement over authoring in vanilla CSS. If I were to start a project right this moment, I'd author it using one of the CSS and JavaScript libraries we've talked about, and I'd feel very enthused with that direction. And so the React community can certainly inspire what many have called selection anxiety. And so the proliferation of libraries and techniques and tooling can make it incredibly hard, especially as a beginner, to know what choice to make and whether that choice is most correct. And so to help alleviate this, I recently created what I'm calling the CSS and JavaScript Playground, which is a live editable comparison of some of the most common CSS and JavaScript libraries. And so my hope is that this tool will help each of you get a feel for each of these libraries and hopefully empower you to make a more informed decision for what is best for your particular app and your particular use cases. Let's do a quick demo of this. Hang on, I'm turning off mirroring for 1 second. All right. So this is the CSS and JavaScript Playground. It's an application that I actually built using React and Glamorous. I'm going to zoom in a little bit. So what it is on the left, you have a code editor, and then on the right, you have a reflection of what that code will produce. It's a real live editing editor, pretty much. And so what I've done here is, given this form example, I've created each of the examples using each of these libraries. So you can get a really good feel for what actually authoring code looks like in each of these libraries. So we have style components, we have JSS, we have Radium, we even have inline styles, etc. There's about 10 libraries or so. It's actually really cool. Can't see Dad submitted Glamorous, so I thought that was really awesome. So let's actually look at Glamorous. So you can see here right away that we're using objects rather than a template string. And so what I added recently is a kind of rudimentary file system. So I can add a ThunderPlains file, and then I can create a title. We'll make this, what is ThunderPlains logo? I think it's purple. We'll call it purple. We'll use this. And then it gives you a helpful import of what the actual import is. Let's use it in index.js. Hello from ThunderPlains.js. We can also, change whatever we want. We can call this CSS and JS Playground. ThunderPlains 2017. And then what's kind of cool about this is, so of course, I'm turning the lights off too. I can copy and paste this, open it in another editor, and you can actually share this stuff with someone else. So I think this is pretty cool stuff, and it definitely solves some of those issues I was talking about with selection anxiety. So if you're interested in this space, definitely check this tool out. I'm biased, but I think it's kind of cool, and I think it can eliminate at least that particular problem. Let's go back to the slides. Sorry, I lost my place for some reason. So if you're interested in this space, here are some people to follow on Twitter. I think that's probably the #1 way I learn about all this stuff and kind of keep up to date. This is a non-inclusive list, but these are some people that I've thought have done some really cool things and have some really interesting opinions on this stuff. And so attributions, so each of these links was something I used to kind of form this talk, and I'm incredibly thankful to each of them. They've done some really good stuff. Some requisite links. So one thing I'll note here is that everything I've built, including this presentation itself, is available on my GitHub. so definitely take a look if you're interested. And thank you for listening. I really appreciate this opportunity for my first conference talk. I hope you guys found this interesting. Thanks.